In order to solve a system by using substitution, the key to it is you have to find the variable that's got the 1 in front of it. So the y is the one that had the 1 in front of it. So I want to isolate the y in the first equation. So to isolate the y in the first equation, you have to get the x to turn into, or the 3x to turn into a 0. So in order for that to happen, you have to subtract 3x on each side. So I know y is equal to 7 minus 3x. Then I have to take that 7 minus 3x and I have to plug it into the other equation where the y is. So when I rewrite this equation, it's going to be 4x plus 2 times y, but my y is 7 minus 3x. And that equals 16. So then you solve your equations. You always get rid of your parentheses first. So 2 times 7 is 14. Positive 2 times a negative 3x is a negative 6x. Bring down the 4x and bring down the 16. Then I've got like terms, 4x and a negative 6x combined to become a negative 2x plus 14 equals 16. Subtract 14 on each side in order to get the x by itself. So I end up with negative 2x equals 2. Divide each side by negative 2. And I know x is equal to negative 1. Now I have to take that negative 1 and I have to plug it back into one of my two original equations. So I'm actually going to take it back and I'm going to plug it in to where I had y by itself. So I know y is equal to 7 minus 3 times negative 1. So that's equal to 7 plus 3. So I know y equals 10. So then I know my answer is negative 1 comma 10. And then I want to check to make sure that that's right. So if that's right, I should be able to plug in to my original equation both of my numbers and I should get true statements. So is 3 times negative 1 plus 10 equal to 7? So is negative 3 plus 10 equal to 7? Yes, it is. So I know 7 equals 7, so that checks. And the second equation is 4 times negative 1 plus 2 times 10 going to equal 16. So is negative 4 plus 20 equal to a negative 16? Or equal to a positive 16? So negative 4 plus 20 is 16. Does 16 equal 16? Yes. So I know I have the